Hi everyone. So let's discuss quadrilaterals. Now we have seen triangles. What is quadrilateral? Quadrilateral is a four-sided closed figure. The way triangle is three-sided closed figure, quadrilateral is four-sided closed figure. So the sum of interior angles of quadrilateral is 360 and the sum of exterior angles is also 360. Now to prove the sum of exterior is 360, I'm taking a rectangle, okay, for convenience. So we know that all are 90 degrees. Okay, so interior is 90 multiplied by 4, which is 360. Now what is exterior? Exterior is when I extend the sides in the same direction. So these are exterior angles. You will see all the exteriors are also 90 degrees because all are straight lines. That's how you get exterior angles are also 90, and 90 into 4, 360. In fact, sum of exterior of any n-sided polygon is 360. Sum of interior angles will change, but exterior angles will never change, the sum. So the type of quadrilaterals that we'll discuss are these: trapezoid, parallelogram, rectangles, square and rhombus, in that order. Now most of you know what is trapezoid. Trapezoid will have two lines or two sides parallel and the other two sides not parallel. Okay, if the other two sides are also parallel, then it is called parallelogram, right? So trapezoid, let's say, is we have two sides parallel and the area of trapezoid, let's say the parallel sides are AB and CD as per the given figure. As we can see, the lengths of these parallel sides are A and B and the distance between them. Now whenever we say distance between them, it's always the perpendicular distance. Remember, the distance between any two parallel lines is always the perpendicular distance between them, right? So area of the trapezoid is half into height, which is distance between parallel lines, multiplied by sum of the sides. Okay, so this is what we have discussed. If a trapezoid has two pairs of parallel sides, then it is called parallelogram, right? So this is about trapezoid, not very important from the perspective of exam. Important one is parallelogram, where the two sides are parallel, like two pairs of parallel sides are there and the opposite sides are parallel to each other. Like you can see, AB is parallel to CD and their lengths are equal. AD is parallel to BC, also their lengths are equal. So considered AB. And the distance between parallel lines AB and CD we have taken as height, which is h. So all the quadrilaterals, area, perimeter, diagonal, all of this you'll have to by heart. There is not much to explain. Area of parallelogram is base into height. Perimeter is sum of all the sides, right? We all know this, b plus a plus b plus a. So 2a plus 2b, which is 2 times a plus b. So properties, we have seen opposite sides are equal and opposite, yeah, if sides are equal, angles are also equal for parallelogram, right? And even these are equal. And this, okay, so if you extend this, you will see that these two are same. These two angles are same because AD and BC are parallel to each other. So what happens is this angle and this angle form a straight line or a straight angle, or they are supplementary to each other. Okay, see, that's what they said. Adjacent interior angles are supplementary. And yes, opposite angles are equal, definitely. Diagonals need not be equal because we don't know what angle is this, right? Now let's say for same length, we can have parallelogram like this. or we can have parallelogram like this also. So what happens is this diagonals will keep on changing as per this angle. Let's say this angle increases further, so become something like this. So that's why the diagonals length need not be equal, but they always bisect each other. That means, what is bisect? Bisecting means cutting in half, right? Like this sides are equal and these sides are equal. All these properties are supposed to be, let's say, remembered, right? Now, parallelogram, if the sides become 90 degrees, it becomes rectangle. Okay, the angles between the sides become 90 degrees, then the parallelogram becomes 90 degree rectangle, sorry. So in rectangle, what? All interior are 90. So area of the rectangle becomes length into width, so which is A into B. Perimeter is same as parallelogram. Now if we want to find diagonal length, so we can see two right angle triangles with two legs A and B. So apply the Pythagoras theorem. D is the hypotenuse. D square is equal to A square plus B square, or D is square root of A square plus B square. The properties: opposite sides are equal, opposite angles, all angles are equal, diagonals bisect each other, definitely. If it bisects in parallelogram, it will bisect in rectangle for sure. Adjacent interior angles are supplementary. Of course, any adjacent you take is 90 plus 90. Diagonals are equal. Yes, both the diagonals are equal, right? So all these are self-explanatory. Now, a rectangle, right, of different lengths will be square if the lengths also become same, right? If B is equal to A of a rectangle, then it becomes square. So area is side square, perimeter is 4A, diagonal is A square plus A square, right? Root 2A, 2A square. So how do we write? Root 2 multiplied by root of A square. So root 2 multiplied by A. This is the diagonal. Properties same, opposite sides, opposite angles, diagonals bisect, adjacent angles supplementary. What additional is, diagonals are equal. Yes, diagonals are equal, but they are perpendicular also, because square is the most symmetric. So they are equal and they are perpendicular also. Diagonals are angle bisectors. They bisect their angles also. That means this 90 becomes 45 and 45. So this 90 becomes 45 and 45. So as we can see, 45, 90 and 45, they add up to 180 degrees. Now the last one is rhombus. Rhombus, a lot of times it's represented like this, but I like to represent it in a diamond shape so that it's easy to remember. Rhombus is diamond shape with all the sides are same, right? And let's say if the diagonals need not be equal, because the interior angles need not be 90 degrees. So if the two diagonals are D1 and D2, area of the rhombus becomes half D1 D2. As you can see, they bisect. That means this length is half of D1. This is half of D1. They also bisect. That means this is half of D2. And this is half of D2. And you can see in rhombus, there are four right angle triangles, four equal right angle triangles. So if you want to find area of rhombus, you need to find area of four right angle triangles. Now, what is the area of one right angle triangle? Any one you take, the legs are half of D1 and half of D2. So half into base into height. Okay. Any one triangle you take, the leg is d1 by 2 and the other leg is d2 by 2. So if you cancel this, what you get is half d1 d2. That is how the area of rhombus came to half d1 d2. Perimeter is same as square. Again, the derivation is not important. This is just for your convenience or the feel good factor, right? Like how it came, but important is that you remember the formula. Yes, opposite all sides are equal, rather opposite angles are equal. Yeah, you can see that it is symmetric. Why I took in a diamond shape is I can see that opposite angles are equal, diagonals bisect each other. We have seen adjacent interior angles are supplementary, absolutely, because if I extend this, I can clearly see this angle and this angle are corresponding angles, right? So they add up to 180 degrees. Diagonals need not be equal. That's why we have taken d1, d2. Diagonals are perpendicular, absolutely. You can see because rhombus is symmetrical. Diagonals are angle bisectors. Yes, they cut into equal halves, right? So no doubt about this. So this is all about the quadrilaterals. So I have just summarized this. You can take a snapshot of this, or you can just remember this or make a chart of this. So I'll see you guys in the next video. I think the concepts or the formulas of quadrilaterals are clear to you. I'll see you. Thank you.